Hi, a very warm welcome to Ushendra's engineering tutorials, a topic from digital signal processing, convolution, which plays a very major role in signal processing. We have many methods in obtaining convolutions. One of the important methods being overlap add method. So what is it, why do we go for? We have when the convolution is to be obtained between two sequences with different lengths, very longer sequence, convolution with the very shorter sequence, then we make use of overlap add method. Numerical, solving a numerical will be very easy to understand. Let's do for that. Considering what is actually convolution, it's a response y of n. What it is, x of n will be given, and the convolution between the impulse response h of n and x of n will be the final output y of n. It's a h of n, okay, impulse response h of n. Considering two sequences, what it may be, x of n being equal to, let it be 1, 2, 3, 2 being negative, 2, 3, 4, it's a 3, okay, 3 being negative, and 3 and 4, 4 being negative. Now this may be, considering this may be our x of n, and impulse response h of n will be, let's suppose 1, 2, minus 1. This may be the sequence. Like convolution should be obtained between these two sequences making use of overlap add method. We have another method known as overlap save method, so that is different approach, same, like let's do it for both methods for the same sequence. Let's match the answer, what will be here. So what actually happens, we need to pad zeros. It may be in the beginning of the longer sequence, at the end of the longer sequence, depending upon the method we go for. In the overlap add method, it will be at the end. And what the very first step, now this we need to have, let the length of the longer sequence be L, length of the longer sequence L, we need that information, and length of the shorter sequence be N. And the longer sequence first, x of n, should be truncated to this length, and we need to pad some zeros, some amount of zeros that will be depending upon this n value. What amount of what number of zeros to be padded? It's n minus 1 zeros to be padded. Here in this case, the length of the impulse response being 3 minus 1, which is equal to 2. Yeah, we need to pad 2 zeros to x of n, 2 zeros to x of n. This is the very first step. Okay, this has to be kept in mind. No, this isn't the first step. This has to be kept in mind. Depending upon the length of the impulse response h of n will give us the information that what number of zeros to be padded to the longer sequence x of n when making use of overlap add method. Right, and what is the next step? This has to be this x of n, the length of we need to have packets of x of n based on this number, right? So here now our x1 of n will be equal to this has to be truncated to this length, in the sense we need to consider 1 minus 2 3. This will be our x of n, 1 minus 2 3. And guys, this is from the x of n. Now we have to pad zeros. What number of zeros to be padded? 2 zeros to be padded at the end here, the second. Now the final x1 of n will be equal to 0, 0. So this is the procedure. What will be x2 of n? X2 of n will be, we are done with this one, okay? We are done with this one. The next sequence will be containing these data. So what is that? It's a it's from here, right? It's a 2, minus 3, 4 from x of n, and this is incomplete. We need to pad zeros and 2 number of zeros from the information impulse response. So it's 0, 0. So this will be our x2 of n. Another one is left over here, 3 minus 4. That will be our x3 of n, which will be, what is left over? It's 3, minus 4, and it's incomplete actually to this length. So we can go for an extra 0 over here padding. That doesn't matter. That doesn't change the characteristic of the procedure. And actual zeros from the padding procedure, it's a 0, comma 0. Now the length is okay. Now how to obtain here from here? How to obtain our y of n? Y of n will be equal to x1 of n convolution h of n. A beginner don't get worried with this one, what the convolution, that isn't rocket science, okay? It's we have procedure, we can make use of a lot many procedures to evaluate the convolution, one being very convenient, one being the matrix method. A beginner, it will be easy for a beginner, don't worry. So this one, y of n will be x1 convolution with h of n. So we need a h of n. This isn't the h of n we make use in the convolution process, that isn't. Now this one, it's now for y1 we have a convolution between, it's the first sequence. What is the first sequence? x1 of n, it's a 1 comma minus 2 comma 3 comma 0 comma 0. Now this is for x of n, and h of n will be the length which is equal to this one. It's a 1 comma 2 comma minus 1 comma 0 and 0. Guys, check the length. 1 2 3 4 5 1 2 3 4 5 are done. So this is the sequences which we make use of to evaluate y of n, right? And y2 of n, y2 of n will be equal to x2 of n convolution. Anything else? It's same h of n, the same h of n, making use of the same h of n. x2 of n is it's here. It's 2 comma minus 3 comma 4 comma 0 and 0 here. This is for x1 of n convolution, the same h of n again from the beginning which we are having. It's a 1 comma 2 comma minus 1 comma 0 and 0. Yeah, making no mistake, 2 2 minus 1 and 0. This is for y2 of n. So what about y3 of n? We have third sequence also, isn't it? y3 of n will be equal to, it's a 3 comma minus 4 comma 3 zeros we have from the sequence, 3 zeros, and this is for x3 of n convolution h of n again. H of n, what is that h of n? It's same, 1 comma 2 comma minus 1 comma 0 comma 0, right? So what to do after evaluating the question, what to do after evaluating y1, y2, y3? That's another approach. First let us evaluate for y1 and then we can go ahead with the procedure. How to evaluate the convolution x1 of n comma h of n, making use of the very simple method, matrix method. How to write that one? Here the beginner shouldn't get confused. All the values, all the data will be gone if the beginner isn't careful in plotting the matrix form. It's y of n, okay, writing that for x1 of n, it's a 1 minus 2 3 and 0 and 0 for the first column. Next column, the 1 starts from here, it's a 1 minus 2 3 0 and 0, okay, and this is for the second column. Third column, 1 starts from here, minus 2 3 0 and 0, and fourth column, 1 minus 2 3 0 0, and for the last column, as far as this sequence is concerned, 1 minus 2 3 0 and 0. This forms the matrix to evaluate convolution, in the sense another column matrix, the multiplication of this and this gives us a y1 of n. For h of n, it's a 1 2 minus 1 0 and 0. Now evaluating this one will give us y1 of n. So here it's making no mistake, be careful in multiplying this one. 1 into 1, that will be 1, plus these are zeros, so that will be 0 plus 0 plus 0, and this one, even these will be zeros, this into this plus this into this, isn't it? So that will be 0, leave it away. This one, this into this, it's a minus 2 plus this into this plus 2, okay, and this into this will be 0, this into this will be 0, and all are zeros plus 0, right? And here for the third row, this 3 into 1, that gives us 3 plus minus 2 into 2, that's minus 4 plus this into this, it's a 1 into minus 1, it's a minus 1, and this is 0, see 0, it's a 0. Just leave it away, waste of time. So 0, it's a 0, again we have a 0 plus 3 into 2, that will give us 6, and minus 2 into minus 1, minus 2 into minus 1, that will be minus into minus plus, that will be 2, and here it's a 0, it will be a 0 and a 0, that will be a 0, that's final over here. 0 0, that will be 0 plus this into the third one, right, third one into third one, that will be minus 3. Why? Because 3 into minus 1, that will be minus 3, and it's a 0 and it's a 0. Yes, we are done. So this will be our, simplifying that one, this will be our, here, what's that value? It's a 1, the first element, and here it's a positive negative 2 and a positive 2. Okay, it's a negative 2, positive 2, that will give us 0, and here it's a minus 5 plus 3, so that should be minus 2, isn't it? And here it's a 8, 6 plus 2, it's a 8, and minus 3 again. So this is our y1 of n. Guys, writing over here, it's a y1 of n is equal to how much? It's a 1 comma 0 comma minus 2, 8 and minus 3. Okay, so that's a y1 of n. Now how to evaluate for y2 of n? That's y1 of n, we have done it. How to evaluate that? For the same procedure, it's a 2 minus 3 4 0 and a 0, and in the second column the element starts from here, 2 minus 3 4 0 and a 0, and for the third column it's a 2 minus 3 4 0 and a 0, and here comes 2 minus 3 4 0 and a 0, and the last column in the matrix as far as this problem is concerned, 2 minus 3 4 0 and a 0, and into this one it's a 1 2 minus 1 0 and a 0. Following the same procedure, we have the value here. It's a 1 into 2, 1 into 2, it's a 2 plus, these are zeros, 4 into 0, yeah, that will be 0, completely 0, dot dot dot, right? And the second element, minus 3 into 1, that will be minus 3, plus 2 into 2, that will be 4, and 0 0 and 0, that will be 0 plus 0. Okay, and here 4 into 1, that will be 4, and 3 into 2, I mean minus 3 into 2, that will be minus 6, and 2 into minus 1, minus 2. Okay, 0 0, that's gone, we are done with that. And here 0 into 1, that will be 0, plus 4 into 2, 8 plus third element, right, minus into minus, plus 3 into 1, that will be 3, and 2 into 0, 0 into 0, that will be 0, so no worry, 0, that will be 0, and 4 into minus 1, that will be minus 4, 3 into 0, 2 into 0, that's it. So this is the, and the sequence what we have, it's a 2 over here, it's a 1, and minus 8 minus 4, it's 11, and minus 4 again. So this is the value for y2 of n. Okay, y1 of n, y2 of n, y3 of n is left as a exercise for you to do it. Now the actual procedure to obtain the final y of n, we need to add it, and we have a procedure for that. The first sequence comes over here. What is that first sequence? It's a 1 comma 0 minus 2 8, okay, 8, and minus 3. Guys, how many zeros were padded at the end? That gives us the information where the second sequence has to start from. The second sequence have to start from here, the second, from here. Now the second sequence will be starting from here. Why? Because two zeros were padded in overlap add method. Overlap save method, that will be something else. In the overlap add method, if it were only 1 0 being padded, the sequence would have started from here. We have padded two zeros, so the second, first and second. If 3 zeros would have been padded, the sequence, this sequence would have started from here. No, as far as this problem is concerned, two zeros are padded and the sequence starts from here. What is the second sequence? It's a 2, 1, minus 4 and 11 and minus 4 again. And where does this sequence starts from? Once again, it starts from this one. The reason is two zeros are padded at the end, and that sequence being 3, 2, minus 11, 4 and a 0. Now this will give us our final sequence y of n. Y of n will be this one. This one comes down as it is 1. This one comes down as it is 1, 0, minus 2, and these two are added. Overlap add method. Overlap add method. These two are added. That gives us 10, and minus 2, minus 4, and it's a 14. 11 plus 3, 14, and it's minus 2 again, minus 11 again, it's a 4, and it's a 0. Guys, keep in mind another important point. It's not done. Another important point to be remembered over here. What is L over here? It was L, the length of the longer sequence, x of n, length of x of n, and n was length of h of n, the impulse response. Now this sequence have to have L plus n minus 1 length. This ry of the length of y of n should be equal to L plus n minus 1. In that process, this 0, the last 0 will be cancelled. Guys, this is the procedure, okay? This is the procedure. Whatever the sequence may be, the length, whatever the length may be, this is the sequence, this is the procedure. L plus n minus 1, this should be the length of y of n. In that case, this 0 gets cancelled, and this is my final sequence for y of n from 1, 2, this, and this is my final convoluted y of n, making use of overlap add method. Where did this start from? X of n should be truncated to the length of h of n, and the length of h of n will give us the information what amount of zeros to be padded, and at the end of the sequence. And convolution is done making use of the matrix method, the convenient method, and this is the procedure. Make a note, please. Evaluating the convolution of the same sequence, making use of overlap save method. The previous one, overlap add method. Now it's overlap save method. Once again, making use of the length of the impulse response to get that information, what amount of zeros to be padded in the beginning or at the end. Guys, remember, very important point, for overlap add method, zeros are padded at the end of the sequence, x of n and h of n also. Okay, and here it's the zeros are padded at the beginning of the sequence of x of n. What number of zeros to be padded depends upon the n value, h of n value, the impulse response. Here the length is 3, it's n is equal to 3, and n minus 1 zeros to be padded, it's a 2. So 2 zeros padded to the beginning. Over here it's a 0, 0, the padded, and so intentionally left this place. Guys, this is the complete sequence of x of n. Now, making use of this sequence, we have to evaluate the overlap, the convolution between x of n and h of n, obtaining the value of y of n, making use of overlap save method. A very important value to be extracted from the given information, which will be the game changer, will change the game of this derivation. What information is that? We need the value of m, some m. What is this m? It's a 2 into n. In this case, it's a 2 into n is the length of the impulse response. It's 2 into 3. So m is 6 over here. What it says? What do we make use of this one? The length of, it's a length again. The length of x1. It should be the length of x1. We need to cut this x of n into pieces, right? It should be divided into x1 of n, x2 of n, x3 of n. The length of x1 of fragmented x of n should be this one, m. Guys, this is a very important one, making use of overlap save method. When we make use of overlap save method, you have to go for this one. You need to have the information of m to, like in this case, let's go for x1 of n. Now it will be here, guys. What's that? It's a 1 2 3 4 5 and 6 up to here, this one. So it's a x1 of n will be 0 comma 0 comma 1 minus 2 3 and 2, right? 1 2 3 4 5 6. Now what will be our x2 of n? X2 of n will be equal to, so do you think we are done with up to this point, right? 1 2 3 4 5 and 6, 1 2 3 4, yeah, we are done with this one. Oh, do you think that we need to start from here? No, we have added 2 zeros, so we need to go ahead. Our x2 of n starts from here. It's the end point. Now this will be the starting point of x2 of n. We need to consider from here. If it were 1 0, we should start from here. If so 3 zeros added in the for the x of n, we should go for this one. And 2 zeros, so we need to start from here. And x2 of n will be 3 comma, it's a 2 comma minus 3 here, minus 3, and 1 2 3 4 5 and 6 here up to here, this one. So 3 minus 3 comma 4 comma 3 and minus 4 being the last one. So do you think we are done with this one? Because we have ended up to here. Do you think we are done? No, we will be having x3 of n. x3 of n will be, where do we start? From here, this one with a red over here again. We start the x3 of n from here. Keep that in mind. So here it's a 3 again, 3 comma minus 4. So the length of this one should be equal to this. That it's a 1 2 3, yeah, this one 6. So padding 4 zeros, that doesn't matter. Yeah, this could be done. 0 0 1 2 3 4 5 and 6, guys, this one. So how to evaluate for y1 of n? Y1 of n should be equal to convolution between x1 of n and h of n, making use of the matrix method. So y1 of n, making no mistake, y1 of n will be equal to, what is x1 of n? It's from this sequence. It's 0 comma 0 1 minus 2 3 2 convolution. What's that? H of n is this one, 1 comma 2 comma minus 1, and this the length of h of n, the impulse response should match the length of this sequence, so it should be padded with, that could be done. Okay, 0 0 0, guys. And the same way y2 of n will be this sequence convolution with this sequence, and y3 of n will be this sequence convolution with this sequence h of n. Make a note, please. Making use of matrix method to evaluate y1 of n. So how to write that in a matrix? Here it should be 6 by 6, right? 0 comma, when 0 1 minus 2, we are not fit with this one, 3 and 2, right? Any missing elements? 0 0 1 minus 2 3 and 2. Guys, be careful. If it's negative, it should be negative, right? All the values get changed and you'll be confused. And second column, where it starts from, it's a 0 0 1 minus 2 3 2, and third column it starts from here, 0 0 1 minus 2 3 and 2. The fourth column, it starts from 0 0 1 minus 2 3 and 2, and the next column, it starts from here, 0 0 1 minus 2 3 and 2, isn't it? And one more here, we need to have one more, 0 0 1 minus 2 3 and 2 here, into h of n. This is our x of n. Into h of n, it's a 1 2 minus 1, and all are zeros, which gives us, multiplying these two, matrix multiplication, 0, that will be 0, 2 into 2, that will be 0 plus 4 from the previous one, 2 into 2, minus 3 here, minus 3, and it's a 0, so multiplying all this will be 0. We have to bother only about these 3 elements. And here it's a 0, it's gone, and 2, the third element into this third element, that should be -2, and no need to bother because these 3 elements are zeros. And over here it's a 1 into 1, it's a 1, 0 0 gone, and here the third element 0, we are left with 0 0 dot dot dot, right? And -2 into 1, that's -2 here, 1 into 2, that's +2, 0, we are done with 0 and 3 zeros, so these will be 0, right? And over here 3 into 1, that's 3, minus of 2 into 2, -4, plus 1 into -1, that will be -1, right? And it's 3 zeros, so no, we don't need to bother about that. 2 ones, it's 2, 3 2s plus 6, and -2 and -1, that's +2, right? Here it's we have, this will be 4 minus 3, 1, -2, 1, it will be, yeah, +2 and -2, that we have a 0, right? And here it's a -5 plus 3, it's a -2, and 6, 10, it's a 10, right? Now this is our, what is that value? It's a y1 of n. Now pause me and evaluate for y2 of n, y3 of n. I've already done it to save the time. y1 of n, the same procedure, matrix method. So how to evaluate for final y of n? Rewriting those sequences once again. It's a 1 comma -2 1 0. I mean, let this be 0 -2 and 10. Okay, and the second sequence, guys, where we have to start the second sequence, it's here 8 12, because of 2 zeros were added, 12 -2 -4 14 and -2, right? And this sequence, it should start from here. It's 3 2 -11 4 0 and a 0, right? And here we have the final, the sequence y of n, the convolution between x of n and h of n, the final, right? Here this one. Now here, how many zeros were padded? 2 zeros, and where it was padded at the beginning, right? We need to discard these 2, the beginning of the sequence. This comes down as it is, 1 0, no adding, okay? We are not adding, so we need to discard these 2 also, these 2, and these 2 comes down as it is. It's a -2 10, and -2 -4 comes down as it is, and even these 2 are discarded from this sequence, so we'll be having 14 -2, and this comes down as it is, okay? This -11 4 and 0 and 0, right? So this is in the final y of n. We have to do something with the zeros over here. Some expert says, some author says 2 zeros were padded at the end, so that can be neglected. And some expert says we have to length, the length of y of n should be equal to this one. What is that? L plus n minus 1 should be the length of the y of n. L being the length of the sequence x of n, and n being the length of the impulse response h of n, minus 1. So as far as this problem is concerned, it was 8 plus 3 minus 1, so that gives us 10. So count 1 2 3 4 5 6 7 8 9 10. Yeah, this is the sequence, my final sequence. Making use of overlap save method, guys. The same sequence, can you see over here? We have evaluated making use of overlap add method in the beginning, so this same sequence, right? Hope you understood the analysis. If you find it useful, support me with your valuable share and a subscription. Thank you for watching.